Coming to my first question, so about your experience with your 30 years of post PhD academic experience in spearheading educational and research programs, especially in biotechnology and bioinformatics. Could you share some of the most significant changes that you have observed in these fields over the years, and how have these changes influenced the direction of your research and teaching methodologies?
Yes. A lot has changed in the past almost 10 to 15 years, particularly in the field of biotechnology and bioinformatics. In the And those changes happened with the development of one technology, which is called as CRISPR technology, which is basically to edit the genes of any organism. So, what we do, like in a Word file, we can edit the words, the spellings, and everything. Similarly, you can edit the genes with this technology. And that opened up several avenues in various sectors of biotechnology, whether it is the medical, healthcare, agriculture, or any segment. The second major landmark discovery has been the development of mRNA-based vaccines, which was developed by Moderna, Pfizer, during the period of COVID-19 pandemic, and that technology gave us within 1 year the vaccines, though that was primarily in the North America and certain parts of the world, but it was a major discovery. And for both these discoveries, whether it is the gene technology with the CRISPR or the mRNA vaccine technology, both these technologies have been awarded the highest prize on this planet in science and technology. That's the Nobel Prize. So that's the major contribution. In the area of bioinformatics, well, bioinformatics came into existence in mid-90s. Before that, of course, biotechnology has been there. But the need of mathematics came because once the genomes started, sequencing, so like getting the information about the genetic makeup, it started with the bacteria, and then eventually to humans, to plants, to animals, to almost everything. And that's where the need of this discipline of mathematics came into existence, that how should we, store this information, and more importantly, because the DNA of an organism is made up of only 4 letters, A, T, G, C. But since there are millions or even billions, like human has 3.2 billion nucleotides. So the next thing was that, how should we extract useful information from this whole genome sequence? And that's where the computational tools were developed and the bioinformatics discipline was born. And both these developments in biotechnology as well as bioinformatics has certainly influenced the research and education, I would say, across almost any sector of the life sciences. Whether it is because these opened up several avenues. Like in the case of vaccine, it used to take 10 to 15 years for a vaccine to come into the market, but SARS-CoV-2 virus genome was sequenced within a few days of the pandemic, and then it was available for the world over scientists, so they could develop quickly the diagnostics, the vaccines, or even certain therapeutic drugs. So yes, it has definitely, these technologies have definitely impacted the education as well as research globally. Yes.
Thank you, sir. Thank you for this. And my second question is like, how do you perceive the role of technology, particularly like you have already told me everything about technology in this field, but in your opinion, what are the most promising advancements in the fields, in these fields, that have potential to revolutionize agricultural practices and ensure a food security for the growing population, as the population is continuously growing? So, in your opinion, what are the most promising advancements in these fields?
Yeah. So agriculture is a very important segment for a country like India, where 60% of the population still rely on agriculture, and agriculture has been there for centuries. Starting from the domestication of the plants, and then selecting the genetically superior plants to grow like. But in the era of 60s, particularly when the India was facing the food crisis, I would say at that time, our late Shri M.S. Swaminathan or Dr. M.S. Swaminathan, who took the initiative and got certain dwarf varieties of wheat and into India. So that really took care. But yes, coming to the role of biotechnology, yeah, well, the genetically modified organisms, which is done through recombinant DNA technology or the genetic engineering, that's one of the major outcome of modifying the genomes or modifying the genetic makeup of organism or particularly plants has really transformed agriculture world over. In India, it has been approved by the government of India only for the GM cotton, which is the BT cotton. That's the cotton which is genetically modified to provide resistance to certain pests, particularly the bollworm pest. So that's one major contribution for the farmers, because they don't really have to spray pesticides too much, which saves the money as well as provides healthy environment both for the overall environment as well as for the farmers who otherwise had to be exposed to the pesticides. There have been several other developments in the GMO sector all over the world, whether it is the development of transgenics which are tolerant to herbicides, or even the most classical has been the golden rice, the rice which has been genetically engineered with the increased amount or the enhanced amount of the vitamin A, though that still has not been approved by the Genetic Engineering Approval Committee of the Ministry of Environment, Government of India. But I'm sure that in the years to come, things would be, taken forward. The bioinformatics, again, has contributed dramatically in the agriculture sector. Most important, as I said before, that the genomes of food crops have been sequenced, and India did participate in the sequencing of the rice genome. That was late 90s or early 2000. Now, how the bioinformatics helps in that sector. So once let's say take the example of rice, once we have this rice genome sequence with us, then we can quickly identify the genes which are responsible for any yield traits, or which, for any other nutrition value or anything. And the other sector where bioinformatics has been very, very useful is the identification of certain molecular markers from those genomes, which have been used for the marker-assisted selection or breeding by the plant breeders. And that has been very, very extensively used in almost every, I would say, institution or the Institute of the Indian Council of Agriculture Research across the country in almost every agriculturally important crop. And not only the crops, but also in the animals as well. There is a national, a Bureau of Animal Genetic Resources, which is based in Haryana, Karnal. So they also have, they are using it for the improvement of animal breeds. So yes, both these technologies have tremendously impacted, and I'm sure it will have a more impact in the years to come when the government really approves more GMOs and other additional food crops. Yeah.
So, like the agriculture sector in India is currently facing various changes, and you already mentioned about a few things. From ranging from the climate change impacts to the sustainable agriculture practices, many more challenges are there. So, how do you think that these challenges can be effectively addressed through education and research initiatives?
Yes, very important question, particularly in today's scenario. So the climate is the most important, I would say, limiting factor in the crop productivity, particularly for a country in India. As I said before, that there are several families or the part of the population whose daily livelihood depends on agriculture, right? And the climate change affects through various means, whether it is the increase of the temperature, or it's the floods, or it's a very high rainfall, or it's the melting of the glaciers. And that is impacting through the shifting of the growing season. I come from the state of Himachal Pradesh, and we can see that certain parts of HP where apple was not feasible to be grown, so it's moving higher and higher because of the change of the climate. And the other factor which really affects the crop productivity or the agriculture, many new diseases or pathogens or pests start appearing with the change in the overall climate system. And that happens even for the humans. When we go into a very different environment, certainly it affects us. But we being humans, we can certainly create our own artificial environment. But for the crops, they have to really sustain with that. So the technology has been there now. I mean, the breeding of the food crops has been undertaken so that we can develop certain crop varieties which can withstand those high temperatures. And the most important factor, which is critical for India, is the drought, because most of the
Yes.
agriculture which is done in India is the rain-fed agriculture. Okay, so there the Indian Council of Agriculture Research has a very major focus on breeding crop plants or crop varieties which can tolerate or which can grow in very limited water conditions, which we call as the drought tolerance. And for that, yes, the role of biotechnology is there. Either we go for genetic engineering or even through the molecular markers. And as of now, the molecular markers are being extensively used, whether it is for drought tolerance, or it's for high temperature tolerance, or it's for resistance to any new pathogens or new diseases. But yes, this is something a big challenge for the years to come, until unless we really take care of the factors which are contributing to the global warming, particularly the emission of these carbon dioxide, which is the sole factor with the burning of this fossil fuels. So yes, biotechnology has a critical role to play in the development of crop varieties which can withstand these adverse effects of climate, as long as it is doable. But once the situation gets out of control, then probably human beings have to really take very drastic decisions to really take care of this problem. Yeah.
Uh, one most, according to me, it is a boring one. It is an important question. Like industry academia collaboration, if we talk about it. Could you share some insights on the importance of collaboration between the academia and the industry, especially in this field like agriculture biotechnology? How can collaborative efforts between educational institutions and agriculture corporations lead to an innovative solutions and sustainable practices, and that can benefit both sectors and society at large?
Yeah. So agriculture education in India has been very structured, I would say, since beginning. And the Indian Council of Agriculture Research, which comes under the Ministry of Agriculture, based in Delhi. So there is a directorate of education, which is administered by the Deputy Director General of Education, primarily for agriculture education. And there are, I would say, large number of agriculture universities. Those are state agriculture universities, which are more or less in almost every part of the country, or every state of the country. There are some deemed to be universities, and there are central agriculture universities also the current government has set up. And many other central universities are also running programs in agriculture, like BHU's one, which I know very well. They do run bachelor's or master's or even PhD in agriculture. And in the past 10 years, several private universities have also started educational programs in agriculture. So agriculture education per se is very solid and on a very good footing in India. Coming to the collaboration with industry and the corporations, yes, I mean, our agriculture education system, or the setup of state agriculture universities, was adopted through the land grant system of the US. That was the foundation of state agriculture universities, and which was a big advantage, because I also did my all 3 degrees from agriculture university in a state agriculture university in Himachal Pradesh, which again had the same education system what typical American agriculture, American university used to have. So that collaboration, and during those periods, or even as of today, most of the senior, I would say, professors, when I was a student, I used to know that they did their PhDs in the US through the inter academic collaborative programs with the foreign countries. That's one. Industry has been a major player. Now, if you look at the developments of hybrid, vegetables, particularly, or hybrid crops, most of those have been coming through the multinationals, with the collaboration of the agriculture universities with those multinationals for testing those, hybrids in India. The other important part, even I myself, as I said, that after doing PhD, I got a fellowship from the Department of Biotechnology, Ministry of Science and Technology, Government of India, to do advanced research in genomics and rice in the US. So there has been extensive effort by the Government of India, not only earlier, but even today also, to really, integrate agriculture education with the foreign institutions as well as the industry. And now there are very good industries in India, who are taking up this lead by collaborating. We very recently set up a collaboration with the Absolute, which is a startup based in Delhi, which mainly focuses on agriculture. That's a very important initiative by the current government of India. Yeah.
Definitely, sir. So my next question is uh, your vision about agriculture biotechnology in India, the future. How do you see the future of agriculture biotechnology in India, and what steps, in your view, are necessary to realize this vision and ensure that India remains at the forefront of agricultural innovation globally, not in nationally, or it should be globally? What your visions are?
Well, the as I said before, that through agriculture biotechnology, the BT cotton is right now growing in the farmer fields. So that is one thing. And the other technology which I mentioned also earlier, the CRISPR technology, which is the gene editing technology, through which you can edit the genes. That's going to play a major role. Now, why it's going to be major role, and why there is little reluctance on the traditional GMOs, because in traditional GMOs, we used to take certain genes from bacteria during the development of these transgenics, and also for many times we taking genes from other sources. Now, with this technology, you don't really have to get the genes from other thing. Let's say if we are to modify rice, I don't really have to get a gene from other source, which was the major concern with the traditional, genetic engineering technology. But I can just take the rice, whichever rice I would like to, edit its genome, whether it is for resistance, or it's for nice, excellent aroma, or it's for tolerance to climate. I would simply, first of all, with the help of bioinformatics or the computational tools and the genomes, I would identify that, okay, which are the genes which need to be edited for the betterment, right? To improve the quality of rice. I would just do the editing in the labs, and then take it to the farmer's field. So there is no concern of any issue which has been raised. Sometimes that GMOs are not good for health, or GMOs not good for the environment. So that is one thing which definitely is going to impact. And CRISPR is making a really a big impact globally. I would say almost every day I would see one or the other research outcome coming out of this technology. So that's one major advancement, I would say, for India. Second one is the genomics era. Through genomics, we can really get to know why our basmati rice is so good. So at least we know that, okay, there are certain genes which are controlling it, and we could develop certain markers for those and use those for the genetic improvement, rather than going for traditional breeding. So yes, the future of agriculture biotechnology is very bright in India, and I'm sure that that would be visible in the next 5 to 10 years, uh, surely.
We also hope that the agriculture sector in India, commonly known as the farmers' country, or as India as a farmers' country, So we all hope that it can grow better in this field sector.
Oh,
So for
yes.
like my last question, and
Okay.
for the students who are interested in pursuing a career in agriculture and biotechnology, what advice could you offer to them? And what skill, knowledge, and mindset do you believe that the essential are essential for the aspiring professional in this field? And how can they prepare themselves for the challenges,
Yes.
opportunities that lie
Yes.
ahead?
Right. Oh, yeah, yeah, very important question. Well, the any education system, whether it is agriculture or it's engineering or it's medical or it's any other profession, one has to acquire the technical competences, agriculture being a professional field. And the technical competencies are, let's say, if somebody wants to go for a bachelor's in agriculture, technically competent to understand the biology or the botany of different food crops, and also to understand the physiology, anatomy of animals, and then have to understand the role of genetics, role of various branches of, I would say, biology, biological sciences. So, and coupled with the technical knowledge is that through very intensive lab exposure during the whether it is undergrad program or it's the master's program. So that's one, that the technical competencies should be there, uh, coupled with the kind of institutions who are offering. So fortunately, at least in agriculture, biotechnology, we don't really see that much of mushrooming of education as we see in other branches like in computer science. Because in agriculture biotechnology, you need to have a very strong infrastructure as well as faculty who are very well trained. The other important component, which has been very useful for a country like India, the Department of Biotechnology, Ministry of Science and Tech, they have started master's programs several years ago in many state agriculture universities, and that master's program has been funded by the government of India. So the Master of Science students who come for the MSc in Agriculture Biotechnology, they are selected through a national entrance exam, and then they are provided a particular institution to do the 2 years master's program. And those institutions have been identified, which are having very good infrastructure, highly qualified faculty, and a very strong academic ecosystem. So that's another, I would say, added advantage in India, at least for the agriculture biotechnology. Even myself, when I finished my PhD, after that I started a job as a faculty in our state agriculture university. The first course I taught was the agriculture biotechnology, and that's in 1992. So you can see 30 years ago, it was already there, right? And it has, grown in a big way. But that's the one part of the education, curriculum education. The other part, which has become very important in the past few years now, and is becoming more and more important for the years to come. So in addition to having core technical competencies in any profession, whether it is agriculture, biotech, or any other area, the employers world over are looking for certain attributes, which has to be there in every professional. And those attributes are whether the professionals or the students, are they able to solve a problem? Do they have a skill of critical thinking, analytical thinking? Are they capable of working in the teams? Do they possess very good work ethics? Do they have very good written and verbal communication skills? Those are the parameters, those are the attributes which have become very essential, in today's time. Even if somebody is a great studious, highly studious person, but still, if somebody lacks in these attributes, then it really puts that fellow in a disadvantage. So I would say that the education of today, in addition to core competencies, also have to have these additional attributes, which, and I personally, since I have been in biotechnology education for almost 20 years now, and the one thing which we have been doing for the last 20 years, how should we, develop these professionals who have the technical competencies plus these attributes. So for that, what we do is that we created a research-enabled project-based learning. Now, the research-enabled project-based learning is that, let's say in agriculture biotechnology, we are based in any part of India. The students are exposed to the real problems of the farmers, okay, and then they are provided certain projects to solve those problems. So with that, they have to learn all those attributes, because when you are thrown a particular problem, you really have to
Obviously.
think critically, right? You have to really build a team. You have to communicate not only with your faculty, teachers, but also with the farmers. So I noticed that most of those attributes, I'm just giving the example of agriculture biotech since the session being on that, but otherwise, that approach has been very, very effective and has really trained professionals, really those who are capable of, facing the world of today as well as tomorrow. Yes,
Mm,
so I
So with all these, I'd like to just add one more question that comes
sure,
recently just came to my mind.
yeah,
Is that the practical learning is more important than theoretical learning, as you just mentioned. So UGC has recently issued a new guideline, mandated the students to do the uh, 60 to 120 hours of internship during their research period. It's mandatory for every student in the who are doing the research. Either they are if they are the 3 year students, they have to complete in fourth semester, I guess. And if they are a 4 year degree courses, if they are in, so they have to do it in the eighth semester. So how do
yes.
you see that? What are your
Well,
views?
oh, yes, yes, definitely. I mean, uh, and I know very well about this internship program, and UGC has recently come up with this thing. But otherwise, internship has been there. As I said, that I have been in this biotech, bioinformatics profession, education profession for almost 2 decades now, and internship has been integral part of the curriculum. Right from the beginning. Now, there are two parts of the internship. One, it has been mandatory for every 4 year degree program student to really do internship at least once, which was around 6 to 8 weeks during the degree program. But most of the times, what I have seen that the students or the faculty who are really good at delivering education, they would encourage the students to do internship almost every year, and those internships being in depends on which sector it is. So if it's a medical biotechnology, the students will do in the hospitals or go for the biotech industry. If it's related to biomedical, then they would go, or biopharmaceuticals, then they would go to the pharma industry. If it's related to agriculture, yes, then they have to go to the commercial agriculture farms or other food processing industries. Internship is definitely very important because uh, theoretical learning is there and that's doable. I mean, you would be able to do it comfortably if you're really very smart student. But learning for doing something would require the practical exposure. Okay, and practical exposure again. A practical exposure. If I'm telling my students that there is a problem in a food crop and this can be solved by doing this and this, but until unless the students are exposed to the those situations through an internship, they won't really understand the gravity of the problem. They won't really value the kind of solutions, the kind of technologies which are required to solve it. So therefore, practical learning has become more and more important again with the passage of the time. The only thing which the institutions have to do is that really implement it very sincerely, so that it benefits the students in their career, in their future, and fulfills the ambitions of theirs and their parents as well. Yes, it's very important.
Really, thank you, sir. Thank you so much. You enlightened me so much that I have like learned a lot of things about agriculture sector.
Thanks, Prabha. Thanks a
Thank you,
lot.
sir.